Okay. Let's switch to the different microphone. Okay, it's as promised, we start 10 minutes later for the first time to allow everybody to get connected, because sometimes a first time is not so easy. But now it's 10 minutes past the scheduled time, so we can start. And yeah, so technical check, the video is working, the audio at my side it seems to be working, but it would be nice to hear from you in the chat whether you hear me sufficiently loudly and clearly. If that would not be the case, then there are still some buttons I can switch. So please put a comment in the chat whether you hear me correctly or not. And if nobody answers in the chat, then I must conclude nobody hears me. Meanwhile, the further items on the checklist, the streaming is obviously on. The recording, let me verify, yes, is switched on. And color issues we don't have in this system. Okay, sound seems to be quite silent. Let's try to improve. Is this better? Yeah, maybe even a bit too much. Wait, I will make it a little bit more silent again, like this. Is this better? I will wait for 1 minute because there is a little bit of delay between the moment of broadcasting and the moment you receive it. It's quite unpredictable. Sometimes that's only 5 seconds. Sometimes that's up to a minute. Okay, audio confirmed. Thanks. Good, then we can start for real. Well, welcome to the 2026 edition of this course on hyperfine interactions and nuclear methods. This is the first introductory webinar where no science will be discussed, but all practical aspects of the course will be put on the table. What will we deal with today? I will tell you what this course is about, who is participating in this course and for whom this course is meant, why we do the course the way we do it, how this is practically organized, and I will give you some study hints for this type of course, and of course we will also look at how the exam will look like. So first, what is this course about? The topic. It has 2 parts. The first part is on the physics of hyperfine interactions. And if you don't know at this stage yet what hyperfine interactions are, these are, you could consider this as all the measurable properties of, in our case, crystalline solids, where the shape of nuclei plays a role. And shape is between quotes, because shape will have a meaning of a 3-dimensional shape, but there is also the aspect of shape in the magnetic sense. So everything that lets a nucleus deviate from a charged point particle. Everything that goes beyond that approximation, that leads to hyperfine interactions. In the second part of the course, we will use these physics of hyperfine interactions to construct a set of experimental methods that make use of hyperfine interactions in order to tell something either about nuclei or about solids. So you can use these methods in nuclear physics or in solid state physics. That is very roughly the topic of the entire course. Who are the people for whom this course is meant? Who can benefit from this course? I would say it's meant for everybody that has a general science education. There is no strict prerequisite requirement of having studied quantum physics to that level or being aware of solid state physics to that level. No, we try to be rather general. For that reason, the approach to the material is conceptual and not mathematical. Hyperfine interactions are often dealt with in a rather mathematical way, so these are not vague statements, everything is backed up by hard mathematics, but that is not what we will use in this course. We will focus on the concepts, on the ideas behind the hyperfine interactions and the experimental methods, and not on the mathematical formalism. Because for most people, unless you are somebody who really works in this field, but for most people, hyperfine interaction methods are an auxiliary tool, and then the mathematical formalism obscures rather than helps the understanding. And the fields in which people interested in this course are situated, that's often physics, nuclear physics or condensed matter physics, but also bordering fields like chemistry, physical chemistry, engineering physics, materials engineering. Everywhere where you work with materials in the broadest sense of the word, hyperfine interactions and hyperfine interaction methods can be relevant. Geographically, this course is open to people from all Flemish and, by extension, Belgian universities. I don't know how that will play out this year, because up to last year we had always a large delegation from the University of Leuven, with sometimes 10 or more students. But there has been a program change there for the present academic year, and their course on hyperfine interactions doesn't exist anymore in the way how it existed before. So up to last year, they basically joined this online course. Now, that disappeared from their program. Still, people from Leuven and from all other Flemish universities are still more than welcome to join this course online if you are interested in this topic. For all Flemish universities, you can get formal credit from your own university by taking this course, and there is an inter-university agreement about this. But it doesn't need to be restricted to Flanders or Belgium. Everybody, wherever in the world, can take this course. And there have been years, especially the years when I was more actively making advertisements, there have been years when there were in this session 50 or more people from anywhere in the world. This has evolved a bit. Now there are still order of magnitude 100 people per year who take this course, but not necessarily at the same time when it is running at Ghent University. The website is open at any time, so if you want to start this course in September or in July or whatever month or day you prefer, you can do that. And that is what most people do nowadays. So this is a bit of a dark number. They don't join our weekly sessions here, but there are many people actively studying on this material. If you are still in doubt, let me give you some arguments why you would consider taking this course. And my first and most important argument is it's a really interesting topic. Of course, that's what I think. If I wouldn't find this interesting, I wouldn't teach about it. But, well, at least there are people in the world like me who find this very interesting. And I hope that in the coming weeks I can convince you that this is not a coincidence, that there are good reasons why this is so interesting. More practically, what often happens is that people start working on a master thesis or a PhD thesis, and they see, we need some extra knowledge on hyperfine interactions. And then they turn to this course, either to the entire course, if you can afford the time for it, or to a subset of the course, the subset you need to continue in the topic you are working on. You will see that the course is very modular, so if you need only a specific part of it, then that's often possible. Or maybe you are just doing research that is not directly connected to hyperfine interactions, but you read a paper where people were studying the very same crystal you are studying, but they use hyperfine interactions, and you want to understand what have they been doing here? Are their results reliable? Can I use this information for my work? So then you need a better background on hyperfine interactions, and that can be a reason to come to this course. Or you come from an entirely different field, you have never worked with hyperfine interactions before, and then you do, for instance, a postdoc in an area where everybody knows hyperfine interactions. You want to catch up. That's also a possibility. And a final one, which is, I would say one of the more important reasons as well. Many people take this course at the final stage of their physics education, and you will notice that in this topic, many of the areas you have been studying before in the physics education come together. You need insight in quantum physics, you need insight in materials physics, you need insight in nuclear physics, you need some understanding of mathematics. I said we will avoid mathematics, but some of the mathematical principles at least will play their role. So all these domains come together in one course, and it can give you the feeling, if I master this topic, I'm really a physicist, or a chemist, or whatever. So much for the motivation. I will have a quick look at the chat. I will regularly watch the chat to see whether any question is there. So if a question pops up, then please just put it in the chat and I will try to answer it as we go. How is the course organized practically? Well, this will be a story that I bet you have heard in many courses so far. A course typically has a lecture, and then you are asked to process that lecture, to study about that material once you have had the lecture, to make sure that you understand everything, and to list the questions you may have. And then in the next lecture, the first statement is typically, are there any questions about the previous lecture? You raise your hand, you ask your questions, They are discussed, and once everything is clear, you continue with the second lecture. And this cycle repeats and repeats and repeats, week after week throughout the term. Then you have some study time before the exam that you use to revise all the material that you have collected, and you do the exam. All fine. That's how a course develops in an ideal world. But our world is not an ideal world. We live in a real world where something different happens. In the real world, you go to a lecture, and many people don't do anything after that lecture. So when in the second lecture there is the question, any questions about the previous lecture? Nobody raises their hand, because how could you if you haven't thought about the material? How could you have a question? So this goes on throughout the term, lecture after lecture, no digesting. But that's not a problem, because you have this study time before the exam, and there you do the actual work. And you go to the exam, you pass, and you forget very rapidly everything you have studied. Because if you cram, if you force this knowledge to be in your head, then it easily disappears from your brain again after the exam. This is the reason why in this course we try to follow a different pattern. We will not go to the ideal world, because, let's be realistic, that will not work. We will also try to avoid the problems that there are in the real world, and the compromise that we try to do is in this way. You will first study the material. There will be no lecture. It's you get the tools to absorb the knowledge yourself. And of course, you will have questions. So you write down these questions. I will show in a few minutes how. And in our weekly sessions on Wednesday morning, like we are here, then the questions you have asked will be discussed. And we will also look at some of the tasks that you will have been doing in the week that came before. And this cycle will repeat for 12 weeks, and then I bet you will need only a limited amount of study time, and then you will be ready for the exam. And you will not forget so easily what you have studied once the exam has passed. So where do you find your course content, everything you need to learn? That is on this website, hyperfinecourse.org, where you see you can visit the website without registration. Everything, almost everything is available without registration. If you do register, and registration means here just giving a nickname and an email address, if you do register, then you can also watch via the website these feedback webinars, and you have access to discussion fora and so on. But the content itself, the scientific content itself, is available for everybody without registration. Once you are at the website, you will see two modules at the top. The Quick Start module, where all the practical information is, and the Refreshers section. So what is in the Refreshers section? These are a few topics that will be used in the course, and that I assume most of you have met in previous courses. But maybe you have forgotten it, or you want to refresh that knowledge. Well, there are a few short sections there where you can refresh that knowledge. Whenever we need part of this during a module, it will be indicated at the start of the module, better go first to that refreshers part if you need it, and then start the module. In the quick start, there you find all the practical info and also a place, a forum, where you can put some information about yourself in order to make ourselves aware of who is studying in this course. Not everybody does that. In practice, mostly people who study this course completely and synchronized with Ghent University do that. So sometimes it's busy there, sometimes it's more empty, but still it's fun to see who is working in the course. I had a look yesterday evening and I saw that apart from the Ghent students of this year, there was also a student from Cuba who had written something about himself. And well, that shows that every part in the world is accessible for this course. Must not be easy to study in Cuba nowadays. I read in the newspaper this week about fuel and electricity shortages. That makes even following a course over the internet a challenge. But because everything is recorded and therefore you don't need to be live, I hope that even with these practical problems, that the course material will still be accessible, even to people in Cuba. Then, if you continue, you meet the 5 modules on the physics of hyperfine interactions. So, no experimental methods there yet. This is a purely physics topic. And after that, after 5 weeks, we have the collection of experimental methods. Now, let's inspect one of these modules and see how it looks like, what you can expect there. Let's click on the module for the nucleus, and then you will see a table of contents with the different parts that will be discussed for that module. And I will switch on the pointer again. Yeah. And you will also have some extra information in the panel that is shown here at the right. So there are 4 topics for this course, 1, 2, 3, 4, and then an optional one, and then some administrative ones. It is roughly estimated that this will take you 2 hours of work, and there are also some optional resources given. A written summary of this chapter, a summary that has been written by a student some years ago, a part of a course text that very long ago I once started writing but never finished, and the online version of this course is a kind of replacement for what once was meant to be a course text, but still the parts that were ready, and they can still be helpful if you study through this online course. And in this case, there is also a link to a very, very good introduction to tensors. Hyperfine properties are mathematically tensors, and although we will not work with tensors in a real mathematical way, it's very good to understand what these concepts are, and that external course text that really explains this very well. So for every module you find a start like this. Possible helpful extra material is listed there. Yeah, that's what I've said. If you then go to one of the topics, then you will almost always find a video where I discuss that particular topic. There will be slides, and you will hear my voice. I'm not on camera there in most cases, and these are, I'm calculating how old are these videos, almost 10 years by now. This is about the 10th year that the course runs in this online way. So these videos are by now 10 years old. Well, hyperfine interactions is not the kind of topic where every week a new major development is happening. It's a mature field of physics. So what was true 10 years ago is still true today. And although there is, of course, development and better detectors and techniques are developed, we will say something about that in due course. But 95% of this material is rather robust and time independent. So these 10-year-old videos still do their job. I was not always, I'm not a professional actor, I'm not a professional radio presenter, so don't expect totally high quality material there in the technical sense. I stand for the science, but the way of speaking and the way how it is recorded is not always really perfect. But yeah, we can't be a specialist in everything. It's good enough, it's decent, and probably if I would repeat this now, I could do this better. I have more experience. But 10 years ago, we were starting with this, and that's how it is. If you look at the settings of these videos, you can have in some cases subtitles in quite a bit of different languages. That's a project that I hope that this year we will bring to completion, where every video will have subtitles in really many languages, automatic translations in 200 languages, such that the course becomes accessible also for people who are not fluent in English. It's technically totally possible. We are only struggling with the way how to automate this, because uploading subtitle files for 200 languages and that for 50 small videos, that is not something you want to do manually. So if we get this process automatized, then you will have these languages available. This is just that same view a bit larger. You will also find for some videos a transcription, so just a word by word written down what is being said in the video. This is also automatically generated, so it's not necessarily 100% exact, but say it's 95% exact, and that can help while studying. Rather than watching a video again, you can rapidly search something in the transcription. There are also printable slides, either with 3 slides on a page or with 6 slides on a page, and there are some tasks for every video. Tasks that you are asked to do in the week that that module is being studied, and you will be asked to submit these tasks. Well, in either this is uploading a file or writing something in a forum or writing something in a forum. So there will be ways how to let me know what is your answer to that particular task. So this is how a module looks like. These tasks, they are always due the day before the feedback webinars. So our feedback webinars will be on Wednesday morning, 8:30 local time. And depending on the time of the year, that's 7:30 or 6:30 in UTC for people who are living in different time zones. To keep track of that, in the quick start section, there is an item with due dates, and there you find for this year the exact due dates with the hour in UTC when the tasks need to be submitted. And in the next item, the feedback webinars, then you find the schedule for the feedback webinars of this year, also with the correct dates and timing. There is also an item there on a mailing list, which is, well, not really a mailing list anymore. It's the Zulip platform, which is an open source project where you can have asynchronous discussion boards. So there is one prepared for this course. You can register there. All information is available at this item. And you can configure it if you want in a way that if somebody posts something to a forum, that you get an email notification about that. I recommend that you make an email notification for the administrative news forum, and that is the forum that I will use for last minute communication. Say it turns out that I have to be somewhere else on Wednesday morning and I can't do the session live, then I make a pre-recording the evening before and put that online. Well, I will notify you about that via this Zulip channel, and either you read it there on Zulip or you have configured the channel in such a way that you get that information also via email. You can also try in a sandbox the use of the forums, but that will be straightforward. And this introductory webinar that we are now doing here, you will find a video of that webinar. It's being recorded as we speak. And the recording of this will be available there. For people who start this course at a random moment in the year, well, they can see the same introductory information. At the end of every topic, you will also find a link to report how much time that topic took you. And that is useful information for me because then I can keep track about the realistic time you have to spend. And then I can, if needed, update these expected time sections. At the bottom of the front page, there are also 3 other important buttons. There is the one where you can ask questions. And if you have a question about the material of this week, well, don't put it in the tasks you submit. No, put that question there. That is a form that I will look at before every feedback session. So if I see that there are questions there, then I will answer them in the feedback session. If your questions are mixed somewhere in your report, then there is no guarantee that I will see it. I will look at every report for sure, but I will not read it always line by line, so I might miss a question. The button at the other side, that's for technical problems, not for scientific questions, but for technical problems with the site. If a video is missing, or a link is broken, or whatever problem is there with the site, then you can mention it there. This is a kind of an alarm button. If you send something here, then I get an email and an SMS that somebody has reported a problem, and then I drop everything and look at what is going on with the core site. That is to prevent that you get stuck for days with a technical problem, but that also means don't use that if it is not really needed. It's a bit silly if I drop everything and then see a message, yeah, there was a problem, there is a typo in this module. Yeah, okay. That it's good to report typos, but not with this button. The middle button, that's one if you have suggestions how the course can be improved as a whole, the general structure, or topics that could be useful, or parts of topics where you have a good source or an alternative view, or some tasks you want to suggest that would be suitable for a particular topic. Well, all these suggestions you can put there, and regularly the course is revised. I look at these suggestions and see, can I make some modifications here and there, trying to make it better. So that's how the course is structured. Then let's look at some study hints, because for many of you this will probably be the first time you are in a course with this particular setup, and the way how you act in this course may be a bit different than the way how you are used to act in other courses. The first and very important hint I want to give is, when you watch these videos every week, make notes while you do that. Why? Well, if you don't make notes, then how will you study? You will have to watch the video again, and that can be very time consuming. So the mindset should be, I will watch this video once, I will extract the information that I need, and I will write this information in some notes or in a scheme or in whatever way you prefer, such that I can efficiently study this later on. If you don't make notes, you will have to watch every video multiple times. Where do you make these notes? Well, that's up to you. You can use your preferred system, on paper or digital, just as you want. You can use these printable slides for it if you want. Either you print them on paper or you have them digitally. And you can, if you take the version with 3 slides per page, you can make some notes at the right hand side. It's up to you. You can use your own system. As long as you make notes, then it's fine for me. Related to that, if there is a particular place in a video where you find, this is something I would want to watch a second time, or this is a place where a relevant picture is shown or a relevant statement is made that I want to revisit later, then write down in your notes the timestamp. This happens in the video with this number. Every page has a number, so every video can be traced by that number. This happens in the video with that number, and it happens at 3 minutes 15 seconds. It looks a bit silly at first to write that down, but you will notice if you try to, a few weeks later, you go back to that video and you try to find that section. If you don't have the timestamp, then you can search for quite a while. Finding the 20 seconds in a 10-minute video where a particular statement is made, that can take 5 minutes or more. And it can be very frustrating and it feels as lost time. So with a timestamp, you will efficiently get to the places you need to be. Of course, if something in the video goes too fast for you, you can pause the video. something that is not possible in a regular lecture, like now, when I'm talking to you live, you can't pause this. If you watch the recording, then if something goes too fast, you have the pause button. It's in this video environment a very normal, intuitive pause button. No issues there. Even better, if you are watching a weekly video and something is not clear for you and you want to hear it once again, rewind and watch that section again, which can be very efficient and helpful in trying to understand something, but is not something you can do in a regular lecture. So an advantage of video again. You can use the slide bar, that will be very well known to you, in order to go back or jump forward. On the other hand, if the video is too slow for you, then speed it up. And there is in this environment, it's at the top right side, there is a button where you can change the speed. I know that I tend to speak rather slowly, especially when recording something. That's a bad habit that I don't get completely rid of, and especially in these 10 years old videos, sometimes it was very slow. So if that is too slow for you, for some people that's comfortable. It gives you time to process, but if it is too slow for you, then just don't hesitate to speed it up. And another very important hint is book time in your agenda to do the weekly work for this course. We have just this single feedback session for a course of, 6 ECTS credits. That's not much. Long ago, when this course still had classroom lectures, there were 3 lectures per week. Now, with this is reduced to this 1 feedback session, so you gain a lot of time that you don't have to come to a class. But if you don't book that time in your agenda, then it will easily be overruled by other demands. So search the moment in your agenda that is most suitable for you, where you don't have other courses, where you don't have other duties, and book that time and make it a habit. This time of the week I will work for this course. Imagine this as the 2 lecture sessions that you don't have to go to. Book them for yourself where it suits you best. It's not the university that books that time for you. It's you who can book the time when it is most convenient. But do book it. Don't let this flow and think, whenever I have time this week, I will study the module of this week. That moment usually doesn't come, and then you have to hurry up the last day of the week to get it done. So no, book it. Okay, that's almost it except for the exam part. So for people who are not interested in the exam, they can stop after the next slides. And so this is just what has to be done before next week. So next Wednesday. What has to be submitted before next Tuesday, because next Wednesday, the 18th of February, we have the first feedback session, but that is based on your tasks that are submitted the day. What should be done by then? Register yourself on the course site, register to the Zulip communication platform, read what has been provided at the sections with practical info and about you. which will not be much new. This will be basically everything I told you here, but it's good to be aware where that practical info is available in written form. And then do the scientific part for this week, Module 1 on the nucleus. Watch the videos of these topics and make the tasks that are listed there. If you have any questions about this right now, you can put them in the YouTube chat. We will go to the chat in a few minutes. But first, for those of you who are interested in the exam, I will outline how the exam is set up. And for volunteering students that are not affiliated to a Flemish university, well, there is no exam. I can't give you credit, but there are some other things that might be relevant for you as well. So first, the exam for Ghent University and for people from any Flemish university. Exams here are on 20 points, and 4 of these points you already have. So right now, at this moment, each of you has 4 out of 20 already secured. These 4 points, they are effort-based points. You get them because you do the weekly effort of making these tasks. If you submit your tasks every week, then there is no issue. You have these 4 points. If there is a week when you do not submit the tasks of that week, then one of these points is subtracted. And you can never get it back. Once it is subtracted, it's gone. So if there are 4 weeks when you did not submit the weekly tasks, you have 0. It cannot get lower than 0. And that means that if you do the exam where 16 points are to be earned, then you can have at most 16 out of 20. I want to stress that for these weekly tasks, it's really the effort that is rewarded. So it's perfectly fine to submit a weekly task with a wrong answer. And this is the moment when we are learning, and learning comes with mistakes. So it's perfectly fine to make mistakes, but you should do the effort. And of course, not a symbolic effort. If I see a task that was expected to be, well, half a page in order to develop a reasoning, and I see 5 words that are clearly there just to be able to upload something, yeah, that counts as not submitted. But if you do a fair effort, regardless whether it is right or wrong, you keep your 4 points. Yeah, that's what I had said. If people want to do it slightly differently, there is the option, rather than earning 16 points on the exam, that you earn 13 points on the exam, and you get 3 points if you write a piece of course text about one of the experimental methods. So if you feel like this is something I want to do, I want to look in detail in one of these experimental methods and write a text that will help students of the coming years, then you can get 3 points for that, and so then only 13 points are left for the exam. It doesn't happen often that people choose this, but it has happened. And if this is something that you like, why not? The exam itself is open book and open internet, so you can access the course sites and anything else on the internet during the exam. Only communicating with other people in the room or outside the room, that is not allowed. there will be typically three different types of questions. Reproduction questions. You get one concept of the course and, explain that. And you have the course with you. It's written. So, that is an easy type of question. Nowadays, you even have AI that can assist you in writing that answer, and I can't forbid you to use that. If it is open internet, then also AI is available. But as in response to that, even the written parts of the exam will have an oral check. So once you are finished with the written part, you come for an oral check, and we will go through some of these sections, and I will try to hear whether you understand what you have written there. Another type of question is an application question. That's more challenging. You typically get a published paper where a hyperfine method has been used to solve a scientific question. And you will see the experimental data, but not the conclusion. And the question is then to interpret these data and to make a conclusion yourself. Also, this is with an oral check. And then there is a part on active knowledge. That is a series of very simple questions where I would say, if you have studied this course for 3 months, then you should immediately know what this word means. And so that will be the question: explain this word, explain this concept. And so one after the other, very fast. Answers are typically one word or one sentence. And in 2 minutes, we try to do as many of them as possible without preparation. So just to measure whether the knowledge of this course is in your active short-term memory. So this is the structure of the exam, and that's also available in the Quick Start session. I suggest 4 possible days for the exam that are all in the beginning of the examination period, on purpose, because you work quite a bit throughout the term for this course. So then it would be a pity to do the exam at the very end of the examination period. The sooner it comes, the more you benefit from your work throughout the term. So therefore, these 4 possible dates. And this is a small course, so there is no date fixed by the faculty, also because people from 2 different faculties can take this course, and so 2 different exam schemes. So I just ask you, if somebody asks to have an exam on one of these 4 days, try to avoid that and temporarily block them. And once the official exam schedule is there, we will see which of these dates are still available, and then hopefully can take one date that suits everybody. For people who are not part of a Flemish university, there is no exam. I can give you no credit, but what I do see happening regularly, that is that people can get credit from their own institution. You tell them to your own institution, I follow an online course at Ghent University. There it is 6 ECTS. Do you give me credit for this? And sometimes people get 6 or 4 or 3 ECTS points from their own university. Sometimes that means that the university writes me an email to ask, is it really true that this person has been taking the course? And well, then I look at the logs of the website and I see whether you have submitted your tasks, and I can inspect some of these tasks. And if that is okay, then I tell this other university, yes, And this person did everything that was expected to do, and then it's their responsibility whether without an exam they give you credit or not. What I can do in any case is to give you an unofficial honor certificate. That is a document with no official value, where I tell where the course is to be found, which topics have been dealt with in the course, and with the statement that I have inspected the logs of the website and that I have seen that this particular person did the work that was expected. So just an unofficial statement, but sometimes people can use that as well as a means to either get some credit or to complete a training program or whatever. And now I'm really finished. Let's go back to the YouTube chat. So if there is a question right now, you can put it here. For the people of Ghent University, I suggest that immediately after this live stream we go to Teams. There is a team for this course created on in the Teams environment, so then we can see each other face to face. That's always better. But for everybody else, or for questions that can be relevant for everybody else, please put them in the chat if there are. I will wait for 30 seconds or so, and if nothing comes, then we close the session here. Okay, I see Dan telling that he will not be in the Teams meeting. No problem. There will be no content there. It's just a few minutes to have seen each other. We will meet at another time somewhere. We'll try to have that organized. Okay, so no further questions. Then we stop this session here. Have fun with the first module, and we'll see each other back in 1 week from now. Bye bye.